Welcome back to the shop, everyone. Today we test belt grinder performance. With some help from Adam Booth.
Now that's a hammer.
His YouTube channel is abomb79. He's got a belt grinder. And from Alex Steele and Will Stelter from Alex Steele channel, they're gonna combine my belt grinders here in the shop, and what you're gonna see is the variety of belt grinders between all of us, and hopefully the differences in performance that we all have here in the shop. So here's the scenario. You're about ready to purchase a new belt grinder or a used one, or you're gonna build one from scratch. Well, it can be kind of confusing. How much horsepower do you need? What kind of surface speed are you after? And generally, how much removal rate are you looking to get when you purchase your machine? Much like when you purchase a new car or a Corvette or a sports car, you know how fast that car is in the quarter mile and you expect it to perform in a certain way. Well, that's the problem, is we don't know or have a standardized test on what to expect when you purchase or build a belt grinder. I'm in a production environment a lot, so I want high material removal rates and I want it quickly. I prefer not to stand in front of a grinder all the time. So here's what I'm proposing. We kind of run a test, much like you do at the quarter mile or a drag race. You know you have a certain amount of horsepower, the weight of a car, but in all reality, is it fast? We run the vehicle over a certain amount of distance and then we get an arrival time or the quarter mile time. So I'm kind of proposing we do the same thing with the belt grinder. We have a set size of material and we grind it over a certain amount of time and we end up with a distance, and now we have an actual performance number of the machine. This test isn't about the belt grinder itself and the accessories and how it works and different orientations you can put the machine in. This test we're gonna do is just strictly about performance, and a test that you guys in your own shop can perform on your own and then be able to compare with me and Adam and Alec and Will. And there's nothing like this for belt grinders, so it should be kind of an interesting collection of information we gather here today. Belt grit, horsepower, and surface feet per minute. These are the building blocks that could make or break a good belt grinder. So this is the test. How much this rod disappears in 1 minute. And the standard's going to be a 1/2 inch round bar or 13 millimeters if you're in metric. The harder you push, the better, of course, so you want to maintain that belt speed at just above a stall. If we're all doing the same thing, we will now have a baseline to compare all our information to. That way, if you go to build one, you know what performance you're after and can build your machine accordingly to what your performance needs are. So I currently have 2 belt grinders here in the shop, so let's test both of them to see how they do. This was a old wood belt sander that I found at a swap meet. It was just the head, so I retrofitted it onto this base and turned the table saw into a belt grinder. So what we have here is 3 horsepower. The surface feet per minute I'm gonna have to calculate, and I'll pop it up here on the screen. I got a very well used 36 grit Norton blue grinding belt. So let's just see how she performs. The overall length is 27 5/16. We're at, what, 25 1/4, approximately 2 inches a minute. So we're gonna replace it with a new 24, and we'll check out the test with this one. Tell me when. Go. 22 9/16 where we started. With the new belt, we're at 17 7/8. So we really removed quite a bit of material there. Okay, the other grinder we have in the shop is this little Harbor Freight thingy. It's got a surface speed of 1185 and a horsepower of 3/4. This is also a 80 grit belt. And like I said before, This is what, $85. So I don't expect performance out of this to be high at all, but this is why we're doing this test. Okay, so let's turn it on. Wow, that's pretty ridiculous. Let's just say this thing rated 3.5 stars on Harbor Freight's website. Let's see if it ground 3.5 stars worth of metal off this thing. We are now at 25 and 1/8 of an inch in 1 minute. You get to actually compare two machines with a real value. This is what I find extremely fascinating. So let's see what Adam and Alec have to say.
I'm using my Wilton belt sander, and this is a 1.5 horsepower motor. It is single phase, 115 volt. The surface feet per minute for the belt is 2850. This is the size 6x48, and this particular belt is a very old, worn out belt. It is a 36 grit, but like I said, it is old and worn out. So let's go ahead and do a test and see what kind of metal removal we get. This is 1/2 inch diameter cold rolled steel, so piece of 1/2 inch, and I've got it cut to exactly 10 inches in length right there. So we'll do a 30-second cut on this and see what kind of metal removal we got. We got our timer set up right there, so let's get going. See, we generated a lot of heat right there. Just cooling it down in the water. So I have removed approximately 1/16. So not very much. All right, so let's swap the belt out for a fresh belt. Okay, we got the new belt on there. This is a 3M 60 grit belt, brand new. We've got it ready to go. So we approximately removed 1/8 of material on this per minute, because we only did 30 seconds there. So let's go ahead and try our test again. Go ahead and cool her off. So, we removed a lot right there. So we actually removed 7/16 of material. We're at 9.5 inches now, right on the 9.5 mark. So 7/16. So that's going to be 7/8 of material per minute using the new 60 grit belt on here.
This is Jason's grinder test. We have 10 inches and 50 thou of 1/2 inch round hot rolled mild steel, 36 grit Norton Blaze belt, product number R980P. We have a 6-inch wheel run off a 3800 RPM motor. And so, 15 seconds, start now. So over a 1/4 of a minute, we ground to 9 inches, 140 thou. From 10 inches and 50 thou to 9 inches, 140 thou.
So what did we learn today from this experiment? I've always gone with the impression is horsepower is king. Horsepower gets you down to the 1/4 mile faster, and the same goes for the belt grinder. The more horsepower you have, you're going to be able to utilize the whole width of your belt to be able to grind a wider part. It also is going to allow you to have a faster surface speed on your belt, which is going to be able to help you pull material off quicker. And it's also going to be able to run a coarser grit belt. So let's take a look at this little grinder right here. Obviously this little machine's running a 3/4 horsepower motor on a 4-inch wide belt. What this translates to is when you go to actually grind a 4-inch wide part on this belt grinder, you're gonna stall it. The effective range that this really has for contact surface is really 3/4 of an inch. So keep that in mind. So how much horsepower do you really need? Look for specs in the range of 1 horsepower per inch of belt. That will probably put you in a good ballpark. Obviously the more horsepower the better, so try to choose accordingly. I would love it if you guys posted your horsepower, your surface feet per minute, your belt grit, and the time that it took to hog off some piece of 1/2-inch material. And if you could leave that in the comments, we can all learn from each other. And I will leave a link in the description below of a speed calculator. So if you want to just plug in your values of your pulleys and your motor speed, it will spit out a surface feet per minute calculator for you. If you're plus or minus 500, that will get us all in the general ballpark so we can have some sort of comparison test. I'm going to be performing this test on the go-kart belt grinder when it comes back from powder coat, so stay tuned for that. I look forward to reading your comments, and I'll catch you on the next one.